Good afternoon, good evening, folks. Thanks for being here. We do, normal coding streams, but this one's a little different. This one's actually a little bit more formal. It's a user group talk, and I'm your host for the night, Sam. And with me, I have my good friend, Sadukie. Yeah, so here we are. This is a user group talk, and I'm just here to learn from Sarah because she is a data whiz, and you're here to talk about GraphDB and Gremlin and all the things, right?
And Gremlin all the things, and hopefully the demo Gremlins will not show up. Hopefully it's just going to be the API, but we will see what it does. Oh, absolutely.
We'll have fun nonetheless. All right, we have a few of our friends here. Hello, Binary Chef. Hey, good to see you. Greetings. Kyle McMaster. I feel like I've known you in person, but Northeast Ohio. Hi. Sarah and me kind of go way back. I think it was funny, like one of the conferences, I cannot remember, like Sarah was introducing me to to maybe your oldest, and she's like, I've known Sam for longer
forever.
than I've known you. Yeah. No, so we go way back. I've lived in like Columbus, Ohio for, 7-8 years, and I've been in Pennsylvania for the last 10. So yeah,
Has it
good
been
to see you.
10 already?
Yeah, it's been 10 years. Yeah. And Conrad, good to see you. Hey, Conrad is one of our regulars from the user group back when we were, doing all the in-person things, which we'll still go back sometime in December. We're, tossing around like a holiday party idea.
Oh, that'd be fun.
So, yeah. I can use your real name, Binary Chef. What is your real name?
His real name is Doug.
I know. We just know you're Binary Chef. Like that's your, avatar. Although, like our social media avatars have been, they've been, we are just tossing around ideas of where we want to be, and it's all good. It's whatever we use, Twitter, Mastodon, whatever suits your boat. We're just here, here and wanting to share and be friends. Okay, so I'm going to start things off with a quick little bit of housekeeping, if I can. My avatar is a ninja. That's what we know you as, Ninja. Where's my screen? There's my screen. All right, and hide that. All right. Can I go full screen? All right, there we go. So yeah, welcome, folks. This is actually the app dev user group, but Sarah, you might find this funny if you try to remember this back. We started way back in Columbus, Ohio, like 2008, I think. It was like Doug Mayer, me, and Chris Ellis, and a couple of other folks. Like we spent like a few years with Windows Phone. It was called the Central Ohio Windows Phone user group.
I remember Cowpug.
Then we were like, okay, let's just call it Windows. We were talking all things Windows, and then we started talking more and more about JavaScript and iOS and Android and voice, and we're like, okay, let's just make it Columbus App Dev, which we thought was generic enough. And then the pandemic hit. Then we were like, okay, we are still tied to Columbus, Ohio, but not we don't always physically meet there. Let's just call it global. And unless we are moving to Mars, I think we're fine with this domain and the name. So, if you're, just here joining us for the first time, tell your friends we are right here every third Monday of each month. And Binary Chef, we actually haven't had you speak in a while. Maybe I'll ping you. December, we might take a break. It's the holidays, but, coming forward to next year. And same goes with Conrad or Kyle. If you want to speak, you're always welcome. So we do have our meetup group and our website. So, tell your friends. These are some of our sponsors who give us the platform and the space to talk. Visual Studio Live, I'll talk about that. That's more of a chain of conferences, and you get a bit of a discount if you come through the user group. We always recap a few things that are going on, nearby. I still have the slide which we mentioned last month because .NET Conf happened, I think, early in November, but all of the videos are now out. So that's a lot of content, to catch up on all things .NET. .NET 7 came out. So if you want to catch up on a lot of good solid content, they're all up there on the YouTubes. I was looking for our sister user group, the .NET user group in Columbus, Ohio, and they meet 4th Thursdays. And Sarah, maybe but I don't see any announcement up from them for this month.
I don't remember what they had planned. I was their speaker in October, and I don't remember them mentioning anything for November offhand.
Yeah, so I don't know. Maybe they're taking a break for a month. And Binary Chef, you're pingable. Yes, I like that, pingable. I will ping you. All right, and again, it's the end of the year is coming up, so a lot of things are kind of winding down. But this is the one last thing that I have on my calendar. This is Dev Intersection. They do two big shows, one in spring, one in fall or late winter. So this one's coming up in Vegas. Again, it's a big show with lots of folks from Microsoft and Google and Amazon. So good stuff. A lot of .NET, a lot of JavaScript as well. It's Polyglot. So that's in Vegas. And then this one's coming up at the start of next year. This is our beloved Code Mash in Sandusky, Ohio. And Sarah, you're involved with this, right?
I am. I am not speaking, but that's because I'm part of the speaker selection committee.
Yay. So, Code Mash is kind of, I've probably been there to every Code Mash other than maybe one or two that I've missed maybe. But it's how I start my year. So it's, all things developer facing and so much more, people skills and, everything else all together into 3 days or 4 days of madness, 2 workshop days and, 2 full session days. So it's going to be a lot of fun. So come and join us in Sandusky if you're, from around the area. All right, and speaking of Visual Studio Live, this is another set of conferences. They do shows in Vegas and Orlando. I just came back from the Orlando show. The next thing is back to Vegas. This is in March, mid-March. So if you're looking for a bigger conference to go to, that's going to be your thing. Kyle is saying, looking forward to Code Mash. It'll be my first time.
Yay! Welcome.
All right, yeah, welcome to the club. Code Mash is super fun, super interesting. There's so much history. It's at the Kalahari Water Resort, and over years, like we've had really bad weather, like snow emergencies where you're not supposed to be driving. But once you're in there, you can be in your flip flops and shorts for the whole week. You're in a giant water park. So yeah, it's a lot of fun. Something going on every night. So yeah, it's a lot of fun. Just soak it in. It's the first time. It's an experience. All right. So yeah, if you're going to any of these bigger conferences, these are all up there, and more things are popping up for early next year. And drum rolls, we are here to hear from Sarah to talk about all things, GraphDB and what does Cosmos and Gremlin have to do with this. So Sarah, over to you.
Excellent.
All right, let me stop mine and bring your desktop up if you're ready. All right, and the stage is yours.
Cool, awesome. Actually, before I disappear too much into Gremlin, I do want to share 3 more links. Sam, I'm putting them into the private chat. If you could post them in the stream. These are 3 more things that people might want to know about are happening. They're Advent calendars starting in December. Yeah. So we have our friends at the Cloud family. They're doing Festive Tech Calendar. So all sorts of Azure topics are going to appear in there. .NET Christmas and CS Advent Christmas are also .NET and C# related Advent calendars. You will see yours truly in there. I'll be doing an Azure Cosmos DB thing plus default Azure credentials. This is the last time you'll see the Gremlin stuff, at least for this year. So I'm excited to show you all Gremlin today. The data that you will see is used in the .NET Conf data. So as Sam mentioned, .NET Conf happened earlier this month, and they did record the sessions. I did a demo of an application then with like .NET MAUI, and then there's a console application and how they both could use Gremlin.net. But today I want to focus on specifically working with graph databases and Gremlin. And so let's just go into what are we looking at. All right. So graph databases. First of all, this is not like your select star from relational databases. Graph databases are a little different. They're used for things like recommendation engines and social networks. They're used for fraud detection. So think of, well, you've heard that Sam and I have gone back forever. And Doug, who's in our audience too, Binary Chef, we've known him forever through various conferences as well. How do they know each other? We could actually draw that out. I can tell you for sure Sam's in my talk. Doug escaped this one, but another one of our friends did not. So we will show how the social chain happens and what that looks like. All right. But graph databases have a variety of uses. The best way to think about graph databases versus like relational databases, because I know a lot of my audience is more on the relational side of things. I've been doing relational for most of my career. Graph just happened over the past few years. I actually caught a talk at CodeMash of all places. There's a guy out of Columbus, Jeffrey Miller, and he talks about another graph database. And so I caught his talk and I was like, oh, what are graph databases? And from there, it kind of exploded. So that's how I ended up here on the graph databases.
That is a very good point. And I'm just going to quickly just double down on that because like Kyle was saying, it's the first code match. This is one of the best things we can do. Just walk into a session or a topic that we have not heard anything about, right? And it just opens your mind like, oh, wow. And I had the same experience on like several topics that I've just heard for the first time at CodeMash. And then I actually went back to speak on that same topic the very next year. So, it just, you never know what piques your interest.
No, you never know. That's between the graph database from Jeffrey Miller and then Brian Sherwin, who's also out of Columbus. He did a talk on Jupyter Notebooks one year at CodeMash. And so I have a version of this talk where I show how to load the data using Python in a Jupyter Notebook. And so it's cool to see how these presentations I saw at CodeMash and how I've been able to carry them forward in now these presentations. But for graph databases and relational, so relational, you think about it from like the relationships of the entities and their properties. You're thinking at that high level, this is a thing, and like, for example, books and authors have names, and books have names, and books have links to authors, things like that. You talk about it at a high level. But with graph databases, you're not looking at the high level, you're looking at the relationships within the data. So we're going to take a look at some relationships, exploring. So I'm going to assume that you're interested in data because you're here. And because you're here, now you know me. You also know Sam, and Sam and I know this guy named Matt. And so Matt's going to come into play as well. So we'll talk about how I know these topics, are interested in these topics. Sam's interested in a topic. Matt's interested in a topic. And if you're interested in learning about topics that people you know and people that they know are interested in, we'll talk about how we go down that path with graph databases. Now, Azure Cosmos DB for Apache Gremlin. I don't know if you noticed on my intro slide that the Gremlin API was crossed out. So in Ignite in October of this year, they announced the new name. And so now it's Azure Cosmos DB for Apache Gremlin. Rest assured, it's still the Gremlin API, but that's its new formal name. So if you're not familiar with Azure Cosmos DB, think of it as it's a database that can work in various modes. So it supports graph databases, document databases, wide column stores. You can do horizontal scaling relational data with Postgres. And then they also have key value pairs through Azure Table. So those are the main APIs that you have for Azure Cosmos DB. Their graph data is with the Gremlin API, hence the for Apache Gremlin.
Quick question, Sarah.
Yep.
And also folks watching, like I told Sarah, like before we started, like I'm going to be your annoying sidekick with lots of questions.
Ask away.
Okay, what does Apache have to do with this?
What does
or
Apache?
Is it just a name?
So Apache is the foundation that's behind this particular package. So Apache, they have their web server. They do all sorts of different things. I believe it's apache.org. They've been around for quite a while. Gremlin is their graph database query language. It's actually part of the Apache Tinkerpot project.
I see. Okay.
So that's where Apache comes from. It's the Gremlin language that we're working with is coming from the Apache Tinkerpot project, and that's why it's Apache Gremlin.
Makes sense. Yeah.
Now, Azure Cosmos DB, one of its strong points, it's awesome for horizontal scaling. So being able to work across multiple partitions, but I want to stay simple right now. I don't want to get into the complexities of horizontal scaling. That is a whole different topic. So we're just going to work with a flat graph, which means that I don't have to worry about the partition keys in this case. Querying, so you can use Apache Gremlin to query with Azure Data Explorer. We can add things using Azure Data Explorer. Then we can also use gremlin.net, for example, or other languages. So like Java, Scala, Ruby. I think even PHP has a Gremlin package. So, I mean, various languages out there have packages where they can use Gremlin to query a database. Now, before we even get into the querying of it, let's get into the basic concepts. So, we're going to think of it this way. There's these, you're going to see circles and you're going to see arrows. And the arrows and their directions matter. I will repeat that a lot. So, rest assured, if you're like, what's with the arrows? It's coming. But these things here, these circles that you're seeing, these are what are known as vertexes. Think of them as their nodes, or another term is a thing. I put entity in there so that you could understand how that kind of comes down with a relational, but now we're at the data level. We're beyond that table level. We'll come into the data and see how does this data all work. So for .NET Conf, what we had is I'm bringing my laser pointer out. So we have a conference, that's an event. I think at one point it was called an agenda in my data for some reason. Data here, this is a topic. You are a person. All of you in my audience are people. So all of you are you. And then these happen to be other data talks that were at .NET Conf besides this one. Now this one tonight we have more queries and we have a lot more time to show. So this is a little bit more in detail, but these are our vertexes. Now the edges, those are the arrows. Those are the relationships within the data. So how are you related to data? Or we have a missing piece here, but that's coming. How are these related to data? How is .NET Conf related to data? We have relationships. We also have the collection of these edges and vertexes. That's called a graph. So something you'll hear me repeat, V is for vertex, E is for edge, G is for graph. Now you're probably like, well, that first letter in each one, really, Sarah? That's pretty obvious. I'm like, but wait until you see the Gremlin syntax, and then you'll see, oh, that's why she says G is for graph, E is for edge, V is for vertex. And I don't think there's an ABC book for it. These are just a few. There's only a few letters you need to worry about. And then labels. So labels are what defines the vertexes, or what defines the edges. We don't show the labels in this rendition, but when we get to the demo, I'll show you where the labels are for the vertexes. I include the labels here because when I design in PowerPoint, I prefer to actually label my arrows. But in the Cosmos DB Azure Data Explorer, you will not see those labels on the arrows. Rest assured, I will give you a grand tour of that as well. But when we're working with graph databases, these are the things you need to know. To know vertexes, edges, and labels. Those edges have directions, and I will explain those when we get there.
Sarah, quick question.
Sure.
So I get that you're getting into GraphDB and Gremlin, but let's just say I am starting up a brand new app for my business.
Yep.
What would help me decide that I need my data stored in a GraphDB type,
How
setup?
are you going to use the data?
Okay. So the how.
The how or the why. Why do you have that data? What are you trying to get out of that data? And then are you trying to look at relationships in terms of the generic things, the entity level without caring about the details? Or are you looking at relationships within the details? If you're looking at relationships within the details, that's when we start talking about graph. Because you are in the details. All right. Back at that laser pointer, not wanting to turn it off. Fine. Okay. So Azure Cosmos DB for Apache Gremlin. Some things to note with the support. So Apache Gremlin versus the Cosmos API. Cosmos API doesn't support everything that Gremlin in general supports. They have a document for that. I will make sure to get you the link for the slides for here so you can see the Cosmos DB Gremlin support and compatibility with Tinkerpop features. Those are kind of important to know about because not all query syntax will be supported. GraphSound v2 is the language that it supports right now. When it comes to, and I'm not going to get into the gremlin.net code, we're actually going to look just at Gremlin queries. But when you're working with like gremlin.net or one of the other libraries, you need to know it's GraphSound v2, because then you need to know which version you're working with in terms of your driver, and then telling it to do GraphSound v2. The other thing is you're going to want to look at your documentation to see how you pass the queries. For gremlin.net, for example, the documentation recommends passing that traversal as a string. Every time I saw that, I cringe like all get out, because it reminds me of like SQL injection attacks. You remember building SQL strings? Oh, things I don't like to admit to, but I still. Oh. So when I saw that, I was like, no. I prefer to recommend using gremlin.net.extensions, because you can do parameterized queries. So it will handle the parameterization for you, which is glorious. Syntax is going to be very similar to what you'll see today with the Gremlin stuff. Gremlin.net 3.4x is supported on the Cosmos side. 3.5 and 3.6, they have compatibility issues with Azure Cosmos DB. So that's why they don't recommend those just yet. And if you're dealing with that code, it's only primitive types for properties. Okay. I'm going to show a slide that has the demo link with a QR code. That QR code will take you to the demo that was done at .NET Conf. It's got a console application. It's also got a .NET MAUI application. And both of those use a class library that has the queries for Gremlin, and uses Gremlin and Gremlin.net, Gremlin.net and Gremlin.net extensions. And Sam, it's all your fault that I went down the MAUI thing, because I see Sam at all these conferences and I'm like, what's he talking about? Oh, he's talking about MAUI. I should check and see what that's about. And so I finally did.
Love it.
So this is the link for those demos. What we're going to look at tonight, though, is we're just going to go straight into Gremlin queries using the Azure Cosmos DB Data Explorer.
Another quick question. So you're going to get into Azure Cosmos DB, but like, what are some of the other popular graph DBs where you can use Gremlin?
Where you can use Gremlin? So AWS Neptune, I know, has Gremlin support. There may be one in GCP. I haven't had a good chance to play outside of the Azure realm. AWS just happened to be the next one I wanted to play with.
So is Gremlin more of, does it care about where the data is stored or the structure of the data, or is it just a querying language that's irrespective of?
It's just a querying language.
Okay.
Working with a Gremlin server. And so if it supports the Gremlin server, as you can see in this case, there's going to be an API that it supports. That helps a ton.
Got it.
All right, let's go ahead and flip over to Cosmos. All right. So this is my Azure Cosmos DB. Now, Azure Cosmos DB for Apache Gremlin, I have to say, is a mouthful. So I'm not surprised that they did not change this part up here. We can see where it says Apache Gremlin API. So that's how I know that I'm looking at a Cosmos DB Gremlin API. Now the things, so we have a database, which is here. That's what this .NET Conf demo is. And then I have a collection or a container. This is called community. Whoops. Quit scaling me. Then I'm going to go to my graph. So my graph lives in this container. Now, let me close that so you can see when I click graph, the graph tab shows up. G.V, this is where things start. This is give me the entire graph with the vertexes, with what are known as the edges. So the edges are stored with the vertex that they belong. Let me explain that a little bit. So I'm going to go ahead and execute this Gremlin query. Okay. I guess let me take a few steps back. So this is the Azure Cosmos DB. And you'll see my URL shows cosmos.azure.com. So I'm looking strictly at Cosmos and not looking at the rest of the Azure portal. So shout out to the Cosmos team for making that possible. But then I come here to .NET Conf demo. This is the navigation for going through like the database and the containers. From this point on, we don't need that. So I'm going to go ahead and collapse that. Give us the desktop room to work with. Now we have the home tab. I don't need the home tab, but I can't make it go away. There's no X, so it's just going to sit there. But the graph, Now, what this graph is, we have a few things to take a tour of. So we have the JSON graph and query stats. That's these things here. Those are actual little tabs for our outputs. So JSON. So when you query Azure Cosmos DB for Apache Gremlin, you will get a JSON response. And so you will see this for both the vertices and for the edges. So for both the things, the nodes, and then for the relationships. So this is what the JSON looks like. Now, don't panic when you see things like IDs, goods, things like that. Gremlin will make it easy for us with working with what we need to. But just so you can see what the JSON looks like under the covers, so that I can show you no tricks up my sleeves. Can't really roll up my sleeves, but trust me on this one. So G.V, this is the JSON response. I'm going to skip graph a minute because query stats is fairly simple. So query stats will talk about the request charge. How expensive does it cost to run that query? This is not $11.16. I promise you it did not cost that much. This is the cost that are used for running the query request units. There is a whole document out there on explaining how Cosmos charges for these things. So I will include that in notes for the show. Sam, I'll get you all these links for the slide notes then, or for the show notes. All right, so query stats tells you performance and how much the query costs. The graph, this is something you can see in Azure Data Explorer. And this visualization is what you'll see in Azure Data Explorer. So along the left, you'll see results. So this is going to show you something about your node, the graph, or how are your nodes connected, and I will expand that. So rest assured, if you're like, that's too small, I will expand it here in a little bit. But then we also have the node properties. Now the node properties, just so you can see, we've got the name, we've got an ID, a label, a name. You're going to see PK equals PK. That's just because I didn't have a partition key. I wanted to work with a flat graph. Everything that is got the same partition key is stored together. And so if I had a partition key stored or set that didn't match with my queries, it could get expensive. I wanted to just show Gremlin basics, not get too carried away into partition. So that's why PK equals PK. That's why you see that in my queries. ID, you can do this as GUIDs. I went with names for my IDs just to make it a little bit easier to write queries and to show it. Label, so label is the type, and then name happens to be the value. I'm going to expand the graph so you can see what this looks like. So I have nodes. Now these are lowercase, which tells me that these are IDs, which we're okay so far. But let's say that I went to data. I think this will get me out there enough. There we go. So now you can see we have IDs, like Talk 72, Talk 71, Talk 70. Everybody knows which talks those were, right? No, even I couldn't tell you. So when you first get into Data Explorer and looking at the graphs, you will see IDs. Again, I went with named ones because they're a little prettier, a little less intimidating than GUIDs. GUIDs are gross. But I'm going to come under Style. So here under Style, I'm going to say Show My Vertex as a name. Notice when I change that to name, the nodes behind now are, hey, that's a capital Y for you, capital D for data. And on top of it, I happen to know that I have different labels, different things going on in here. So I'm going to say, change the colors of the nodes based on their label. Now showing target sources, I'm going to say all neighbors. That means show all of my edges. Show the sources, which is edges are coming out of me, arrows are coming out of the node, and targets. Where's that arrow pointing? Okay. I'm going to drag this up so you can see what that looks like.
Can I ask you a quick question here?
Oh, absolutely.
Again, while you're kind of drilling into this, like the vertices and their properties, are they stored as JSON?
Mm-hmm.
Okay. And I'm guessing like I see like a new vertex UI up there. So Azure lets you enter those things fairly easily with all their properties.
Yep, I
Okay,
could
there
come
we
in
go.
here and I could
Yeah.
do that. And I will show you how to do that with Gremlin. I actually don't use this interface much because it's one of those I'm like, oh, what properties did I put where? I'm like, yeah, I'll just do it in code.
And is there a way to kind of mass ingest the whole thing as a big JSON database type thing?
So there's bulk executor support for the Gremlin API, and there's document out for that. And then there's also, you can run queries. So in my demos that I did for .NET Conf, there's I think I did 4 different functions just to break it up because I didn't want to have big queries. But I loaded the talks, the non-talks, the relationships for everything except the talks with topics, and then I loaded the talks with their topics.
Sure. And folks in the chat room, feel free to ask any questions of Sarah.
Oh, please do.
This is all informal.
All right, so our data, remember those talks, like talk 71, talk 72? Now we actually have titles. Let's see if it's gonna, there we go. So you can see there's like a leveling up data talk. That's a entity framework talk. Event sourcing with Martin and Postgres. And there's this talk. So when you're looking at the graph, you can see there was a .NET Conf. You can see the arrows and things like that. So G.V is glorious because it gets you everything. Now you can kind of expand and poke around like I'm doing here. So I don't necessarily need Gremlin if I'm working on a small database. I can do that. Notice it says 1 to 10 though, so there are some limitations with whatever tool they're using for this visualization. Now that I don't happen to know off the top of my head. However, it's pretty cool that they have graph representation. I just closed it down so I could see my G.V again. But I have the .NET Conf vertex selected. How do I know? It's because of the properties here. So I could see that this, I labeled it as an event. So I did go back and update my code. Sources. So that is any relationships that are going to come to me. And then targets are relationships coming out of me, then going to somewhere else. So .NET Conf has relationships with targets of like data. So .NET Conf covers data. .NET Conf covers a keynote topic, covers web, and so on and so forth. If we go back to you, because honestly, it's all about you. You're here. Let's include you. So if I go to you, you can see you're a person. Your name is you. You are interested in data. But you might be interested in some other topics based on the people you know and who they know. So we're going to get to there. All right, so that's G.V opens up the world and allows us to explore. I'm going to minimize that and scroll up. All right, so G for graph, V for vertex, and E is for edges. Now, edges, unfortunately, don't have a cool representation on the graph. They don't say, hey, I'm here. No, they're just JSON. JSON and query stats, and that's it. Now, the thing to know with edges, so edges are stored with their out vertex. So let me bring up the graph so I can actually talk to an example of that. So the you are interested in data. You also know sadukie. We'll talk about that later. But you can see these edge labels. So we're talking about labels on the slides and how they don't appear in this visualization. They do appear over here on the properties. And so I could see that because I have these targets, they are stored with my U vertex. Now, I don't have my tools loaded on this machine to show you, but the demo I usually do for this is I'll open up Visual Studio Code. My friend Hassan Sabran, also known as Sabran Web, he has an Azure Cosmos DB SQL Studio extension. And then I show this database and just a select star from to give people an understanding that you can query it with the core SQL. Just because you can doesn't mean you should. It gets gross quick. That JSON is optimized to work for Gremlin.
So on that point, I mean, compare this to like a big SQL relational thing. I mean, here you have, what, a dozen or so, nodes. In a real world, what if you had thousands and thousands of nodes? Like, is this a very expensive performance like operation? Like, if you want to get all of your nodes together?
So this is going to be just like any other tool that we use. It can be expensive if it's not modeled correctly. It can be expensive if it is not optimized, if your queries aren't optimized right. So just like any other querying language and data, things need to be optimized. Your data model needs to be optimized. Your query needs to be optimized. And I noticed you said thousands and thousands. A lot of the places that are working with this kind of stuff, though, are usually with millions. So
Yeah, you said details,
scale.
right? Yeah.
Yeah, and when you're going to that level, you probably are also doing horizontal scaling. So being able to store your nodes based on a certain partition key, then querying for that partition key and only that partition key, so that you're not doing cross-partition queries, which then gets more expensive. So cost-wise, it will always come down to it depends. There's plenty of documentation out there from Cosmos with their recommendations on how do you do the modeling for graph databases, how do you do the modeling for any of their APIs, and then also performance tips and tricks. And indexing is still a key thing too. Like on the SQL side, we have indexes to help with our performance. In graph, the indexing is done with all the different properties. Each of those properties has an index. So, yeah. All right, so these edges, these targets are stored with their source. Okay. So G.V, G.E, again, edges, just JSON. Now, Sam's like, you only have 12 nodes in here. Thanks, Sam, but that's not actually true. Let me get you how many nodes I have in here. So we're going to do a G.V.count. So G.V.count, I want to go ahead and execute the query. So I have 108 vertices in there. And of those vertices, let's see, how many edges do I have? So if I do G.E.count, 107 in there. I've added vertices and edges as I've done this demo, so you'll see all sorts of numbers. If you watch the videos and you're like, why are her numbers never the same? This demo changes often. It's because I try to tailor it either to a group or to add more queries. Now, dedupe. So I guess this is a good point to show Gremlin is a pipeline language. So it's ran from left to right. So G.V, so give me the vertices. That label is telling me I only want the labels for those vertices. And dedupe, give me the unique ones. So these are the unique labels for all of the vertices. So I have person vertices, I have event vertices, I have topic ones, and I have talk ones. And I could do the same for G.E. So edges also have labels. Now, in this case, edges can also have properties, but I don't demo that just because I don't have any edges that require properties. But if you have relationships that you might want to store, such as maybe you're doing reviews, for example, of like Airbnb or hotel or something like that, and you want to keep track of like the number of stars or the date or something like that, if it's relevant to that relationship, you may put that as a property as part of the edge. I guess that also brings another point. So I've had a question when I've done this where people are like, okay, what if we have this in relational data and we want to look at it from a graph perspective? We want to get down into the data and see these relationships. Do you bring in all of those fields? And the answer is no. You only bring in what you need, what is relevant for whatever questions you're trying to answer. So only bring in the data you need, which means only bringing in the properties you need. So I could have brought in things like, all right, so I know Sam. When did I first meet Sam? I could put that on the edge. Things like that, if it were relevant to what I was looking for.
And I'm guessing like you could drill down to only like the nodes of the type person or of a certain label.
Oh, that's coming up actually.
Okay.
Did you see my script?
No.
I did not share my script with Sam, by the way. So for example, maybe I wanted to see, find me the vertices that have the label of topic and their values in dedupe or for talks or for person. So I could do stuff like that.
Oh, I see Matt made it in there.
I told you, our friend Matt did not get away from it this time. And I don't know why there's one in there that's had a PK. I probably had a bad query somewhere in there. So we're going to do the other thing I'm going to show you. So that has label is checking the label. But if you want to say I want to see something with a certain property, I could say has name data, for example, take me to that data node. And then what's nice is because I'm querying with a vertex as my result, so whatever this last thing is at the end will determine if I'm getting vertexes or edges as results. It's always going to be, well, almost always going to be a vertex or an edge. There's two queries I have at the end that show something totally different. But for the most part, vertexes and edges. So you can see here, data has all these different relationships. Now I could also do something like our friend Matt has the ID of integer man because I used our Twitter handles for IDs. And so you can see Matt. So Sadukie knows Matt, and Matt's interested in GitHub, and we'll tell that story. All right. So that's how you get the properties. And you can do the same thing with E with the has label. And you could also do if it had any properties, you could do has and then the property name for that as well. Now let's talk about some navigation here. So let's say we wanted to look at data. So I want to bring our data frame. I'm going to take the any off a minute just so we can get that visual on. So we're going to look at data and let's take a look at in E. So, excuse me, all the relationships coming in. We should see in our JSON results 2 nodes. One is a person, one is an event. So these relationships pointing at it, those are known as in E. They're coming into it. So go here, in E, and execute. You'll see the one has a person. Oops. And the other is the event. Now if we do out E, this is going to be the ones coming away from or coming out of the data topic. And you'll see that we have with edges, there's in V labels and out V labels. So that's a good indicator of what types are pointed. So I'm at data. Data is a topic. What's coming out, or what is it coming out of? It's going to a talk. So there's a few of those. The in V and out V here, these are IDs. I just happen to use clean ones here, no GUIDs, except we may have some that we add later that we could have doing its thing. All right, so we've looked at G.V and G.E. And let's look at in and out. If you wanted all of the edges, so we could say then instead of in and out, we can just say both. Oh, both E. So that will give me, there's the talks with topics, and then there's the events, and there are more. It's just on the screen, the scrolling, it'll kind of scroll by. So you can see that it's got all of those. You can come to query stats, so you can see the request chart. There's not really a lot of information on query stats, but just so you're aware that that's what's going on there. Now, when go ahead.
I was going to ask, like, I can see this type of query being useful, where you want to know what people are interested in, so you can have like targeted things sent to them. So no matter where the notes are, you're looking for a thing that has a common interest. So yeah, we're back at that relationships level.
For me, when I'm dropped into graph, these are some of the queries I start with. It's just the exploration. So what are my labels? What kind of values? What kind of counts? So let's take a look and see that. If I wanted to see the labels, and I'm going to group it by the label name itself, and then count the initial values for those labels, you'll see that there are 6 persons in here, 1 event, 18 topics, and 83 talks. So a few more than those 12 that you thought I had. Quite a few. Can do the same thing for edges. So when I'm doing exploratory analysis on my graph data, I'm curious to see what kind of data is in there. What kind of relationships am I looking at? Things like that. So that's where G.V and G.E call group on there. So group and by, think of it like your SQL group by. But you're going to see here that I have a group, then a dot by, and then another dot by. If I accidentally, as I tend to do sometimes, I'm like, well, I want to group by label, and then I want to group again by that. Well, that's going to give me an error. But the thing is, you don't want to have another group there because that other group is going to reset. Order does something similar as well. I'm just going to put that back in there. So group by, and then the next thing I want to group by, there's this values of label dot count in parentheses, just so you can see where those parentheses add. So I'm going to count the values for that label in that group. The other thing I could do is if I wanted to do ordering, I could do order. So say I wanted to order the talks by their name, I could. So you could see these are all the talks. You'll notice that one of the talks has a heart in there. So your Unicode characters are supported. Works fine. I did actually insert it as a heart. If you pull it on the code, you will see that the heart is in the code. Anytime I could do that, I will. Just to show you that it is possible. Something to note with my talks. So I'm going to get the first talk. So I'm going to say limit 1. So limit, think of it like select top. And the reason why I want just one is I want to look at those properties. So you're going to see that I have a time field here. Notice it is a capital T. But you're probably wondering, is this key sensitive? Let's find out. So I'm going to show you this query where I type time lowercase. Laziness, it happens. Notice in here, I am looking for all the talks. And I'm going to order it by name. And I want to get their values for their name and their time property. Well, name is lowercase. Time isn't, though. There are no times in these results, just the name. All right, fine. Capital T. So you have to match your case for whatever properties you're working with. Be aware of that. Now, something else that you're seeing here is, this is just coming back as a flat array of strings. But what if you wanted to have their properties and their values? That changes from values to value map. And now you can see name and time. So you can control the JSON by understanding the gremlin. If you want just values, that values it is. If you want just properties, you do that properties, but value map is typically what you're going to want if you're getting both that key and that value.
Yeah, and never having played around or done anything with Gremlin, like this is easy to follow. Like you can also bring your SQL knowledge and kind of see the similarities of what you're doing.
If you can think of it as the queries that you want to do in SQL, some of that stuff does apply to Gremlin. Now, what makes Gremlin shine is being able. So these other queries, I could think of their SQL equivalents just fine. But what if we want to do the social navigation essentially? So what I have here, let's do this. Let's go back to the graph representation, and I want to do G.V that has label person, so you can see my people. Ignoring the PK one. Notice we have some IDs in there. something got messy in there, so I'm going to delete that. Yeah. Delete that. Yeah, so you can delete the vertexes that way. I could also do, I'm not going to take any chances. I didn't have any other fields to do it with. But you can see here, okay, so you in sadukie and sambasu and mat. Let's look at that. All right, so you know sadukie. I, as sadukie, happen to know Sam and Matt. You are here because you like data, but you're interested in learning about other topics as well. So you want to know the people who know these things. What are they interested in? Better yet, what are Sam and Matt interested in that you might be interested in? You may not know Sam and Matt, but you know somebody who knows Sam and Matt. So notice how now we're looking at the tiers of that. That gets into gross subqueries. And could you imagine subquery upon subquery upon subquery? That performance hit goes really quickly. This is where graph excels, that kind of navigation. Now,
yeah, so you're essentially, sorry to interrupt, but I mean, you're essentially saying, had you put this type of data in a relational thing, like the traversal of the graph is so much faster in Gremlin.
Yes. Okay. Yeah, because it's what it's built to do. Now, I guess I also have to acknowledge, keep going back to SQL, that SQL does have a graph capability that's coming up. I've started hearing people talking about it, and so I'm curious to see. I haven't played with it much, but SQL does have graph, and it isn't with Gremlin. Unfortunately, they went with a different, getting closer to a different standard. All right, so you know me. I know Sam and Matt. Sam, let's see if I can. So Sam, if you're looking at the .NET Conf stuff, you're probably going to be interested in those client topics because those client topics involve, of course, .NET MAUI. So I had to put that in there. Well, then what about our buddy Matt? What's Matt interested in? So let's go back to sadukie. This is when it just says it's done. Oh no. Come back. I don't know what happened there. We'll bring it back. Graph. G.v that has label person. All right. Notice my style is reset, so I have to come back under style and say I want to show the name and I want to map to label so I can see the colors. Show all neighbors. I want to see all the edges. Show vertex's name, map to label. Okay. Oh, because I'm looking at persons. That's fine. Okay. There we go. All right. So we saw Sam would be interested in .NET MAUI. Matt would be interested in GitHub. Why GitHub? Because I didn't have AI as an option. So GitHub. And then he would be interested in possibly the GitHub Universe thing or Microsoft DevBox, for example. So the question that we have here and that we want to see with graph is, okay, knowing that sadukie knows other people who are interested in topics, what kind of topics are they interested in? How do I get there? Well, we just walked through that. So let's go back to sadukie to bring back you. And so you to here, to out, and to out. How do we write that? All right, so let's go and collapse our full graph. I'm going to paste this query so you can see what it looks like. I'm going to do it. Well, first, let me see if I can copy and paste that. We've already added Matt's relationships and you guys in there, so that. So G.v, I'll zoom it in. Go away, grammar. G.v. So we're going to start at the vertex. All right. Now the has ID you. So we are starting with you. Sam, you're in here twice. Sorry. We're just starting with you. Now I have this repeat. Repeat has not made it into any of my other demos or any other presentations. This is actually exclusive now to the global app dev group and moving forward. So this is a new one to show. But we're gonna go starting with you. Who do you know? So out E knows. And then who does that person know? So I could say out E knows NV, out E knows NV, but I'm going to use repeat because repeat's cleaner. I'm going to say repeat this out E knows NV. Repeat this twice. So start at U, go out. Let's see if I can. Didn't let me expand it a bit. No, I'll zoom in. So you start at U, out E, knows, to sadukie. And sadukie, who does sadukie know? Well, I happen to know 2, so it's going to traverse both of those. And it's going to take us to Sam and Matt. And then I'm going to go to them and find out what are they interested in and get me those topics. And so notice I get client and GitHub.
Perfect.
Nice, quick query.
Yeah. So here you're repeating it twice because you want to go like 2 levels down.
Exactly.
If you wanted to know like who are the people that I follow or I know, and then what are their interests, then it's like 4 levels down.
And so we can go even further. Correct. Yeah. And I could write this very query. So I could, instead of taking, I'll take the repeat out just so you can see what happens. I'm going to take out the repeat and I'm going to take out the times. I'm just going to copy and paste my out the knows. That knows is the label. NV, where's that relationship going to? And notice that gets us there as well. But repeat and times is a lot cleaner to read. So this is where graph shines, is being able to do that navigation. I'm going to take that back out so you can see, I can say repeat. What am I going to repeat? So that's the pattern I want to repeat. And then the number of times I want to repeat it. And that's a 1 based for the times. Execute. What did I mess up there? Oh, there's a period there.
There's extra period.
Yep.
Okay, so maybe another fundamental question here. So, I mean, all of your, comparing this to maybe relational things, so all of your nodes and edges and their relationships, they're all essentially on this particular document or on this particular instance of Azure Cosmos DB. At what point do you know that you have to expand? Like, are your queries hitting a certain, limit? Or you're hitting like a size limit? At what point do you have to scale? And then what does this look like if you're going cross-machine?
So when you're going cross-machine, don't think of actually going cross-machines like physically. You're going through horizontal partitions. And that is something that Azure Cosmos DB manages. So that's nothing that you need to do other than the partition key. And that you usually don't have to consider unless you're working with really large data sets. I'm going to say probably getting into like maybe thousands, hundreds of thousands at that point. When you start to see query performances hit, it's like, oh man, that query looks really expensive. Okay, then it comes time to, okay, do I need to repartition this? Now, if you're already starting with a large data set, you're not going to come in like I am with the PK equals PK. You're going to go through Azure Cosmos DB's graph documentation. They have a particular document out there for graph modeling. And so understanding how do you choose the right partition key for your graph for going horizontal with it. And they do that with their other APIs as well. Horizontal scaling is a huge thing for Azure Cosmos DB. Huge in that it gives so much performance benefits when everything is set up properly. If everything is not set up properly, it could be very expensive as well. So
makes sense. Binary Chef, Douglas Torrance. Good to see you. Good to see you, my friend.
Thanks, Doug.
Go have dinner. Go do whatever you're doing. Yeah, we're just hanging out here, learning more from Sarah. All right.
All right. All right, so that's where that shines. Now, there's one more thing I can show from Gremlin syntax in terms of, okay, how did I get there? What are the steps I took? And this is one of those outputs that doesn't return a vertex or edge collection. It returns the steps that it took to get through there. So you can see that it's going to navigate through the JSON step by step and say, okay, it went from here to there. Here's the types, the IDs, the labels. You'll see the properties for the vertexes. So all the details for building that traversal are there. Now, Cosmos adds one step further on top of it, and we can change from path to execution profile. Now, execution profile is specific to Azure Cosmos DB for Apache. Gremlin is not part of the gremlin.net or any of those libraries. You won't find it in there. So this is a query that you'll have to run as a query string rather than as a Gremlin parameterized query. But you can see, here's the Gremlin syntax that you ran. And it'll show you each and every step along the way. It shows the time. It's going to show the resource usage. It's going to show percentages of where does that fit compared to the whole query. See the results along the way. You'll see any of the operations. So this is useful when you're working with Gremlin and you're wondering, how expensive is this? What's wrong with this query? Why is it so expensive? Run execution profile. Use that to see along the way, oh, why am I doing this? Why am I doing that? One of the things to keep in mind too when you're deciding on your model for graph databases is that your out edges are stored with the in vertex. Your in edges are not. Your in edges means that it has to fan out and query for, okay, what are the vertexes that have out edges that come to here? So that makes it a little more expensive. So understanding your relationships, and sometimes you might have to have a circular, not a circular reference per se, but just in terms of traversing. So we could say something like, okay, well, I know Sam. Sam knows me. I already did that sadukie knows Sam. Let me show you what that query looks like for adding that relationship. So you can see that I know Sam, but Sam doesn't know me. I don't have that relationship in there. If I were to do just g.v has ID sadukie, go to Sam. Whoa. Sam does not have any relationships coming back to me. But maybe we have a query where we do need to optimize for that. Then what I would end up doing is I run the Gremlin query. Oops. It has ID sadukie. I know. Has ID semi-deep. And I'm going to add the relationship that Sam knows. And this is going to go to, so coming out of me going to Due-KAY. So notice it comes back with an edge. And if I take that off, just query for you and expand our graph, now you'll see that I know you and you know me. So this kind of relationship is fine. It's not going to cause issues, but it allows you to then be able to query using the out on that case as well. So understanding your queries with the execution profile will help you to determine where do you need to add those relationships. And that's something that as you're looking at the data, you may realize that the way you worded the relationship might not make as much sense compared to your queries. So then you have to rework your relationships. That's just a high-level welcome to Gremlin. There's so much more it can do, but I don't want to go too much over time. So respectful of that.
Yeah, this is very eye-opening, very, very interesting. And I have a few questions in mind, maybe a couple. And again, folks in the chat room, please feel free to chime in. So you started with like social networking. So much of what we see is this, right? In today's day, and this gets complicated very, very quickly.
It can.
Especially when you're saying like the ins are not stored as a part of the nodes themselves. I can see like that being very, very expensive on a very, very large like data set.
Exactly.
Yeah. What are some of the like? Have you heard of any like real world challenges where these things were super expensive? And then the couple of things that come to mind is like in the Twitterverse, like when you put out a tweet and then everything gets drawn out as a graph based on likes and dislikes and retweets, and then traversing that gets expensive, and then the whole edit thing. Editing your Twitter, that is a very, very expensive engineering operation. So, I mean, do you have any stories? Is essentially I'm asking.
I don't have any good stories about that yet, and that's just because I haven't poked at them enough. I suspect that there's more than just graph data going on there.
Yeah.
So typically, if you see graph data, it's probably not by itself. Where did that data come from? How else is it stored? Because I've seen graph data that originated as document data. So, and think like a MongoDB or Azure Cosmos DB, NoSQL API, I think is what it is nowadays for NoSQL, something like that. But yeah, I don't know how they would handle that. So hold on, let me get you the link for the data modeling, because that was one of those that will have you thinking a bit more. There's
a link.
Yeah, since I can't post it in the comments, I'll just post that there and you can copy it.
So like the data modeling thing is essentially important because that's what defines the performance of what you're trying to do.
Absolutely. Absolutely. And then when you're going into like partition graphs, so that's when I talk about the horizontal partitions. So that's the next link I just posted. That's how do you choose a partition key? And that goes back to everything goes back to thinking about how are you going to use that data? What fields are you going to query? How frequently are you going to query them? Reading and writing makes a difference too. So how frequent are you going to be reading versus how frequent are you going to be writing? Something else that I think about usually is like if you're storing things in a graph or a relational database, then you want to pull from a data feed, and then transition it into a graph database. You could do that as well.
I see. So like, I mean, have your transactional things maybe in a SQL or document DB, but then pull from it and have your relational database somewhere else where you can traverse the tree much quicker.
Exactly. So think of the databases as using the right tool for the right situation.
Yeah.
So when you actually want to get down into the relationships within the data at the data level, that's where graph comes in. And you're like, I just need to, I don't know, maybe build an invoice with all these different invoice lines and things like that. Relational database for something like that.
Yeah, no, this is fascinating, and there are so many options we have nowadays. A lot of us have looked at Mastodon, which is a distributed social networking, and that has a whole other set of worries. Like if you're implementing this, because now, like you have one server with all of the nodes that's talking to another instance, and you have all of these relationships and so the data might stay on one thing, but you have relationships all over the place. So,
Yeah, it gets tricky understanding it all. That's over the past few years, I've been doing a lot more distribution for distributed data from like document perspective, from graph perspective, and then recently with Postgres, and just playing with that. It's mind blowing when you come from a flat relational world to then have to scale, and you're like, wait, how did that work?
Yeah. So many real world scenarios are driven by stuff like this.
Oh, absolutely.
Yeah. No, this is great. So thanks for sharing the link here, because that's your demo. And you have some resources here too.
Yep. So actually, I'll give you. So this is the demo link. Grab the demo there. The demo does include console code and the class library code and the Maui app. So that'll help there. If you want to see how to work with gremlin.net. And then we have additional resources, so all sorts of cheat sheets, the compatibility, so understanding what Azure Cosmos DB supports. There's the Tinkerpop tutorial, which I love the most because it gets really in depth with Gremlin. It takes it from what I gave you tonight, it goes even further. It gets into deeper things, which is, it's awesome to see just what Gremlin can do. And again, that whole looking at the layers and how are things connected and how those things are connected and those other things. So being able to branch out like that, that's awesome. So that's where these things come into play. And then
Tinkerpop is a funny name. Where did they get that? Is there?
I don't know. That's a good question. Where did they get the name Tinkerpop? Oh, Apache and their Tinkerpops. The Tinkerpop itself is the graph framework, and I want to post that link in our chat as well. How did they come up with the name and with Gremlin and things like that? I don't know. There's got to be a team and a community, because that's usually how Apache works. Big on both.
Yeah, I for some reason I never knew that Gremlin was an Apache thing.
I didn't know about it until Azure Cosmos DB, honestly. As soon as I saw it had a Gremlin API, I'm like, ooh, it's got graph data. I was already playing with Neo4j and Cypher. So I'm like, okay, let's go learn another graph language. Can't be that crazy, is it? No, it's easy. It's easy.
Yeah. All right, and I see you have a link for the bulk executor as well, and Tinkerpop tutorials, Gremlin cheat sheet. Yeah.
Yeah, so all of those are available. Like I said, I'll make the slides available in a spot where you can see it.
So maybe another question here. So let's say you are in a traditional relational SQL database type situation, and just the way you showed us the execution profile, like most relational servers will give you an execution profile as to how they're executing their query. And if something is being slow, you go to your DBA and you fine tune how you're storing the data, how you're indexing it. Here, it comes down a little bit to your knowledge as to how you're modeling it, right? And what those relationships are. So you could keep your nodes, but you could redraw the relationships, right?
Oh, absolutely. Yeah. Okay. Yeah. And when I'm building a graph database, the first thing I'm looking at is what are my things out there, and I'm usually drawing on paper, like I don't know if it's going to show because it's a virtual background, probably not. So I was trying to explain this to my son, like what are graph databases, and so I was drawing out circles, and I drew a circle with his name and a circle with mine and a circle with my husband, and showed how he's the son to us. And I was explaining his connection between us and Mark Rober. I don't know if you're familiar with Mark Rober. He's a NASA engineer who does some pretty cool stuff, like an obstacle course in his backyard for squirrels, amongst many other things. So I was explaining to him that he's connected to Mark Rober through my husband, because my husband spoke with him at they did a keynote at an IT conference earlier this year.
Yes.
And then Mark Rober happened to be in a video with Mr. Beast, who's another one of those YouTube sensations that my boys are all excited about. So I'm like, okay, so now you could be connected through Dad, who's connected to Mark Rober, who's connected to Mr. Beast. Or you can connect to me, who's connected to Dad. But because you're connected directly to Dad, that's a shorter route. So that's how I explained to him. That's but I drew it on paper first to show him, and he's like, "Oh, you draw on paper?" I'm like, "Yes, I draw on paper. Always go in with a plan."
Yeah, it helps to visualize and see. Like I need to look up chat room. Kyle McMaster is saying squirrel mazes are awesome. I have not heard about this.
Oh yeah, Mark Rober's YouTube is awesome. Things he's done with like the elephant toothpaste and the glitter bombs for the people who are trying to steal the packages, the Amazon packages. Mark Rober did those. You have not? Oh my goodness. Yeah, Mark Rober is going to.
So what happens? Like if somebody tries to steal, you throw glitter on them?
It is hilarious the things he did. Yeah.
Oh, okay. All right. I got some YouTube homework for tonight, which I'll gladly accept.
Yeah. So he does all sorts of fun stuff, but I use that to show to my kids. This is what kind of stuff that Mom talks about. And I do that when I do all my graph databases. I draw it out and I look at the relationships like, is this really the story I want to tell? Are these the right relationships? Then if it's not right, then I'm back to drawing board. But I will usually draw it because I get lost and my mind goes in circles with ins and outs that if I don't draw it down to write the query, it's hard to do.
So you dropped the link into the YouTube.
Of course.
Yeah, of course. Yeah. Yeah, and you never know. Like while you are walking through this graphs, like you're also sparking imagination in your
absolutely.
kids, getting them to think about these relationships. Yeah.
Yeah.
Very cool. Very cool. Well, Sarah, I cannot thank you enough for spending an hour and a half of your evening with me and with the chat room here, dropping in knowledge, getting us excited. This has been
awesome.
wonderful.
This has been fun. Thank you all for having me.
Yeah, and QR code and right there, email, and that's where you can find Sarah and all the things that she does. What's your next in-person thing? Is it CodeMash?
My next in-person where you will see me is CodeMash. I don't have any in-person talks scheduled now until. That's a good question. I don't think I have any in-person.
Yeah, and it's starting up for next year. Yeah.
A lot of the stuff that I have right now is virtual. You'll see next up is Festive Tech Calendar, C# Advent, and .NET Advent. They're all on December 6th. So you will see me on all of those. Some of that is going to be Azure Cosmos DB. I'm going to be using their NoSQL API. And I will be using Azure Identity SDK in C#. So being able to show how you can develop against these password lists and not have to store your credentials anywhere near a file that would end up in GitHub, for example.
Makes sense. Yeah, this is great. I see the GitHub IO link in there. I will drop that in as well. Yep. You are very, very organized. I love it.
I try to be.
I'm all over the place when you have everything organized together nicely. It's very nice. So yeah, people, this is where to go find Sarah, sadukie.github.io.
Yep.
All right. So chat room, thanks for hanging out with us this evening. This is the one thing we do miss about non-in-person user groups, because this is the time where we bring out the pizza and play some ping pong or some board games. But I try with my family to have a pizza night on the third Mondays. It doesn't always work out.
It's not the same.
No, it's not the same. But hey, at least we get to hang out and learn. So yeah, thank you everyone. Thank you so much, Sarah. And,
thank you, Sam.
Yeah, this has been great. I'm going to bring your desktop down here. And Cal's thanking you as well. This is a big shift in mindset. Yeah. Oh, there you go. DDD in web apps.
Very cool. Very cool. Hey, Kyle, when you're at CodeMash, if you see Sam or myself, come say hello. We love talking to people.
Please. All right, folks. I think that's it. That's what it's going to be for tonight. And Kyle says will do. So thanks everyone. Thanks Sarah, and stay well, stay productive, and we'll see you. We'll see you on the next stream. And until then, take care.
All right. See y'all.
Bye for now.